Hi, let's continue street fighting mathematics. So today we are going to discuss um, the second topic, easy cases, but in that we are going to try to calculate the volume of a truncated pyramid. Okay, so the truncated pyramid, which is also known as uh, frustum. Okay, so now let's see how to calculate the volume of this one. So in order to calculate using a street fighting method, so now we see three variables. Okay, so the volume is what we need to calculate. So the volume is going to be function of what are the variables. So we see three variables. One is this distance, okay, and another one is this distance, okay, and the third one is height. So it's going to be a function of height into height a and b. Okay, well, here we cannot use the dimension analysis because all the variables are having the same dimension. Okay, so here it's the dimension analysis will be not much helpful. Okay, let's see how to solve things. Now look at this picture. Okay, so if you look at this picture, this is a little chunk which is a chunk in this truncated pyramid. Okay, and now let's say if I double the height, okay, if I double the height, what will happen to the height of this little chunk? That height will get doubled. But what about the area of this little chunk? That's not going to get doubled, or that's not going to get modified. Okay, so when I double the height of the pyramid, okay, the height of this little chunk is also getting doubled. And this little chunk, not only over here, even if I put a chunk over here and where it just getting cut at that surface, okay, even that one will also, the height will get doubled but the area will not change. Okay, the cross section area will not change. So which means if only the height is getting slightly it will get changed, but if you make this chunk very small, then you can assume that only the height is getting doubled. Okay, so which means the volume of each little chunk is getting doubled. If the volume of each little chunk is getting doubled, then the total volume is getting doubled. Okay, so from this what we can say is v is equal to, so f of 2h comma a comma b is actually equal to 2v. Okay, so from this what we can say is the volume is proportional to height. If the volume is proportional to height, so instead of writing like this, what we can do is we can write v is equal to h into some g of a comma b. Okay, so we can write it like this, g of a comma b. Okay, now instead of identifying this function f, now all we have to do is we need to identify this function g, which is with only two variables. Okay, fine. Now we need to identify this function. So what are the possible combinations or with the variable a and b can have? So g of a comma b, should have the dimension of area, because the volume is having a dimension of L cube, and here H is having a dimension of L, which means G should have a dimension of L square. Okay, so what are the combination of A and B will provide me the L square dimension. Okay, maybe A square, okay, and B square, AB, A cube divided by B, B cube divided by A, then like A to the power of n plus 2 divided by B to the power of n, and all these, and then B to the power of n plus 2 divided by A to the power of n. So in general we can say that any of such combination with the n being an integer is possible. I mean n will be, yeah, n can also be 0, right? So from past 0, 1, 2, 3, and it can be any number, so anything is possible. Okay, so if anything is possible, then right now what I can guess is the solution could be any linear combinations. Okay, not just A square or B square, but any combination of these terms are possible. Okay, so which means we have infinite possibilities. We'll see, we'll identify some more easy cases, and then we'll try to narrow it down. Now let's go to some easy cases. If you see the easy cases, say one case is, say A is equal to 0. Okay, and another easy case is B is equal to 0, and the third easy case is when A is equal to B. Okay, so when A is equal to 0, so just once again I will write this: G of A comma B can be any A n plus 2 divided by B n, and also B n plus 2 by A n, right? Where n could be any integer, 0, 1, 2, and right. So in that case, what shall I just think, could n be a negative integer? Just think. Okay, fine. Anyway, now if we notice, when I substitute A is equal to 0, okay, then look at this term. Okay, below we have A to the power of n, and that will make this term to be infinite unless n is equal to 0. Okay, so in that case, and similarly for this case, when B is equal to 0, then this term will get shoot up, so it will be better that this A and B should not be in the denominator. So the terms which are not being in the denominator are A square, B square, and AB. Okay, so these are the terms which weren't being in the denominator. Okay, so in that case, what I could say is the solution could be alpha A square plus beta B square plus gamma into AB. Okay, now let's look at this third easy case. When A is equal to B, okay, we know the volume is H into, let's say, A square. Okay, so then what shall I say? Let's see, when A is equal to B, what am I getting? Alpha a square plus beta. Now a is equal to b, so this is also a square plus gamma a square, which is equal to, so for this case g of a comma a is just a square, so that comes from here, right? Because volume is h into g of a comma b, so therefore g of a comma a is a square. Okay, and now alpha, if I take a square common, alpha plus beta plus gamma is into a square is equal to a square, so that leads to alpha plus beta plus gamma is equal to 1. Okay, fine. And one more thing, look at the previous slide and this picture, what if I change a in the place of b and b in the place of a? So f of h comma a comma b and f of h comma b comma a. Okay, so I just change the dimension of a to b and b to a. What will happen to the volume if I do that? Will it be same or different? Actually it will be same. Okay, so what does it mean if a change to b and b change to a? It just mean it will give the same volume, because it just nothing but I just flipped the whole truncated pyramid. That's it, isn't it? So for that reason these two things are going to be same. If those two things are going to be same, okay, if those two things are going to be same, then it means if I flip a in the place of b and b in the place of a, then let me write it over here. So alpha a square plus beta b square plus gamma ab should be equal to, in the place of a I'm going to put b, alpha b square plus beta a square plus gamma ab. Okay, so if these two things are going to be same, then what can I say? So what I can say is alpha is equal to beta. Okay, if alpha is equal to beta, then look at this equation. From this equation I can say it's 2 alpha plus gamma is equal to 1. Okay, see, all I'm doing is just some intuition, and then I'm just deriving the equation. Okay, so we are not there yet. So all we need to do is, if I identify what is alpha and what is gamma, then we have the solution. Okay, right. So now let's look at this case. Let's say I'm taking a cube with a dimension of, say, b. Okay, this is b, this is b, and this is b. And now I'm going to take a pyramid, okay, where a is 0, b is 2, and h is 1. Okay, where in this cube also b is 2. Okay, so 2, 2, and 2. So what is the volume of this cube? And that is 8. Okay, the volume of this cube is 8. If we have a pyramid like this, okay, if we have a pyramid like this, which is what shown over here, okay, so they have inverted the pyramid, and then they just inserted that pyramid in this one, in this cube, so that this tip will be at the center of the cube, okay. And since this base is 2, and say this will be 2, this will be 2, and it will just occupy this entire surface. The base of the pyramid will occupy this entire surface. Okay, so now I have inserted this pyramid in this cube, and it is being like this. And can I similarly insert one more pyramid with the base which is covering here? And yes, okay, without interfering on this pyramid, okay, and that pyramid will again, the tip of that pyramid will also just touches here, okay. And similarly, for each face I can have one pyramid, okay. So which means the total volume of the number of pyramids which I can put inside is 6, okay. So in that case, for this case, okay, the volume of pyramid is 6 into the volume. So this is the volume of pyramid with this case, okay. And the let me call this as C, okay, the volume of cube, which is equal to 6 into volume of pyramid, okay. And we know what is the volume of cube, which is 8, okay. In that case, what is the volume of pyramid? Vp, which is with height, maybe I will, which is equal to height, which is 1 into g of a, which is 0 comma b, which is 2, and that's equal to 1 into, and now we know what are the possible combinations, right? So alpha a is 0, so into 0 square plus, once again that's alpha into 2 square plus gamma into 0 into 2, right? That will be the volume, and this is equal to so alpha into 2 square, which is 4, okay. So the volume of the pyramid is alpha into 4. But what is the actual volume of the pyramid? So that we can calculate from here, right? So Vp is equal to 8 divided by 6. So this is also equal to 8 by 6. So alpha into 4 is equal to 8 by 6. Then what's alpha? So alpha is that's 2, and that's 1, and if we cancel, that's 3. So alpha is nothing but 1 by 3, okay. So we have got our alpha. So from here we conclude, we haven't concluded, so far what we have, what the result we have got is V pyramid is equal to height into g of a comma b, which is equal to height into 1 by 3 a square plus 1 by 3 b square plus gamma, which we do not know, into A into B. Okay. Now what we shall do is, let's go for one more easy case. Okay, and that one more easy case is, which we have already seen. So let me rewrite that result. What we have got is, so g of a comma b is equal to 1 by 3 a square plus 1 by 3 b square plus gamma ab. Okay, so we know that g of a comma a, which is equal to a square, right? So which is equal to 1 by 3 a square, that comes from the first term, plus 1 by 3. Now I don't have to put b square because b is equal to a, so once again a square plus gamma a into a square. Okay, so then 1 by 3 plus 1 by 3 plus gamma of a square is equal to a square. So from this quantity is equal to 1, and in that case gamma is equal to 1 by 3. Okay, so what's the conclusion? The conclusion is volume of the truncated prism is height into 1 by 3 a square plus 1 by 3 b square plus 1 by 3 a into b, which we can write it like h by 3 into a square plus b square plus ab. Okay, that's it. So all we have done is some simple geometric understanding we have used, and then we have calculated it. Okay, now what I'm suggesting is, you just try to calculate the volume of that piece, okay, using calculus. Okay, and just see how hard that is. Only then you will appreciate our method. Okay, and then additionally what you could do is, you just instead of a truncated prism, you just use a truncated cone. Okay, so maybe, sorry, and then just see whether you are able to get some answer in this simple method. Okay, so you guys give a try, and we'll see. Thank you.